Hi, welcome back. Today we have a question which is the 40mm diameter smooth horizontal part of figure here transport 0.004 meter cubic per second of water at 20 degrees Celsius. Using the power law profile, approximate A, the friction factor which is F, B, the maximum velocity, C, the radial position where U equal to V, which is in this case it is a Y, and the wall shear, tau, E, the pressure drop over 10 meter length, which is delta P, and lastly the maximum velocity using equation 7616. Alright, so the first, let's take a look about the question. The question asks about the friction factor, maximum velocity, radial position, wall shear, tau, pressure drop, delta P, the maximum velocity using this equation. Okay, now our first step, what we need to do is, in order to get the friction factor, okay, to get the friction factor, we can get from the power law, which is F. Okay, we can get directly from here. N equal to 1 over square root of friction factor. Okay, but in order to get the power law, which is N, we need to get the Reynolds number. Because from Reynolds number, refer to table 7.1, we can directly get the power law N. So in order to get Reynolds number, we know that Reynolds number is rho V, okay, rho V d over mu. Okay, or you can say rho V or rho Vd over mu or Vd over nu. Okay, so now let's use this one. Because under 20 degrees Celsius, under 20 degrees Celsius of water, we can get directly the value of V. The mu here is 1.007 multiplied with 10 to the power of negative 6. Alright, so we have nu, we have diameter, but we don't have the average velocity. It is not given here. So in order to get the average, we use the continuity equation because it is given that the flow rate is 0.004. So using, okay, step number 2, using Q equal to AV, okay, we can get average velocity. So rearrange back, average velocity equal to Q over area. So Q here is given 0.004. 0.004 over with cross-sectional area. Alright, so in this case, you look at the cross-sectional area, which is, this is the circular shape. Alright, this is, let's say, your eye. You can see is circle. Definitely the area is pi r squared. So we use the radius, which is 20 millimeter. Okay, so we can use directly the formula of area, pi r, which is 20 millimeter, convert into meter, which is 0.02 square. Alright, this is area. So you will get the answer is 3.18 meter per second. Once you get the average velocity, step number 3, you can get the Reynolds number. Reynolds number is Vd over nu, which is velocity average 3.18 multiplied with diameter 40 millimeter. Alright, so 40 millimeter convert to SI unit 0.04 meter. Okay, over with This is kinematic viscosity. In this case, 1.007 multiply with 10 to the power of negative 6. Then you will get the final answer of Reynolds number to be 1.27 multiply with 10 to the power of 5. Right. So from the Reynolds number, as I mentioned before, we can get the power law from table 7.1 in the textbook. So step number 4, using Reynolds number, we can get the value of n, which is in this case, you can see this table 7.1. This is correlation of Reynolds number with power law n. So let's take a look. We have Reynolds number 1.27. So this one, there is not there. We have to do the interpolation method. Okay. So I believe this is in between this range. So we need to create one table. Okay. This is Reynolds number. This is n. Okay. So Reynolds number is, we start with the smallest one, 10 to the power of 5. This is referred to 7. And this is our number. Our number must in between those number. So our number is 1.27 multiplied with 10 to the power of 5. This is our number that we are looking for. And this is 10 to the power of 6. We continue here. Okay. This is referred to 9. Okay. By using the interpolation method. Okay, let's do the interpolation. So how to do? Of course, x is more than 7. It is increasing number. So x minus 7. This is 1.27 10 to the power of 5 minus this number 10 to the power of 5 over, this is over 9 minus 7, 9 minus 7, and this one 10 to the power of 6 minus 10 to the power of 5. Okay, so from here, okay, you do the interpolation, you will get, using your calculator, you will get 27,000 over with 900,000. Okay, and x minus 7, you simplify, you will get 0.06, and finally you get x equal to 7.06. This is actually the number that we are looking for, which is n here is 7.06. After we get the value of n, we can get the friction factor from this formula. Alright, step number 5. Okay, we can get the friction factor from this formula. Okay, we can get the friction factor from n equal to 1 over square root of f. Okay, so we make f become the subject, which is 1 over n squared, because this is b squared both sides. So 1 over n, and previously is this one, which is 7.06 squared. Our friction factor now become 0.02. Now we have solved the question 1. The question A asks the friction factor. So how about to get the maximum velocity? Alright, in order to get the maximum velocity, we can correlate with the power law. Once we get the n, we can get straight away the value of maximum velocity. So let's continue. This is step number 6. By using the in order to get the U max, okay, we can use the correlation of U max with the power law, which is here is n. So it is mentioned here that U max is actually equal to n plus 1 to n plus 1 over 2n squared multiplied with velocity average. So from here, okay, from here just substitute the value u max equal to n. Our n here 7.06. Just substitute here. 7.06 plus 1 and 2 multiplied with 7.06 plus 1 over with 2 multiplied with 7.06 the power of 2, and this is multiplied with average velocity, in this case 3.18 meter per second. Then you will get your answer to be 3.4 meter per second. Now we have solved for the u max using the power law that we found previously. So the next question asks the radial position where the u equal to v average. So that means different layer will have different velocity because we have the velocity profile. It distribute the change of velocity profile will have at the different layer. So we need to find what layer will have the u equal to v. In this case 3.18. Okay. So from here we know that this is our velocity profile. Okay. Different layer will have different velocity. We start at this one. So which layer we call as the R, which position, radial position, have the velocity u refer to v. In this case 3.18 average velocity. You can see 3.18. So next, by using the equation, in order to get the radial position, which is r, which position of r when the u reflect to the 3.18, we can use the equation here. Okay, this is step number 7. Okay, in order to get the radial position, as I mentioned previously, that reflect to the u equal to v, which is in this case 3.18 meter per second, we can use this equation. Okay, u bar over u max equal to y over r naught. Okay, 1 over n. You can see we have the power law here, and then we need to find the y. Alright, this is the part. Let me explain a little bit. This is our velocity profile. Okay, our y will start from here. This is our y. And definitely, this is our r. Okay, in order to get r, okay, this is total, we call as r naught. In order to get the r naught minus y, you will get the r. Okay, so first we need to find the y first. Okay, so from this one, u average, okay, we find previously using the continuity equation. So make it this one, y become the subject. So here, u bar over u max that we found previously, the power of n multiplied with r naught. This is the radius, the total radius of the pipe. So u bar 3.18 discovered from the flow rate over with u max, which is previously we know that u max is 3.4. 3.4 the power of n. Our n here refer to 7.06. So n here is 7.06 multiplied with r. Okay, which is in this case 20 millimeter. Okay, you can see it is given that the diameter 40 millimeter. So we can multiply with 20, or we convert into centimeter. It should be okay. Okay, radius equal to 20 millimeter. We convert into centimeter, it becomes, okay, 2 centimeter. Okay, so how to do that? This is 20 multiplied with 10 to the power of negative 3. Okay, so it becomes 0.0123, 0.02. So in order to put the centi is 10 to the power of negative 2, we have to multiply this. We need to reverse this one. 1, 2 become 2 dot centimeter. Alright, multiply with 2 centimeter. And finally, you will get the answer is 1.247 centimeter. Alright, after we get the value of y, which is reflect to the distance from the wall surface of the part, we need to get the radial. So from this one, using this equation, r radial, the radius, the length of the from the center equal to r naught minus y. Alright, so from here, in order to get r naught minus y, which is in this case r naught is 20 millimeter. Remember our pipe diameter here is 40 millimeter. So radius, the total radius is r naught. So 20 millimeter convert to centimeter, it is 2 centimeter. So 2 centimeter minus with y, which is this one, 1.247 centimeter. We will get the final answer is radial position 0.753 centimeter. So in this case, this is a center. Okay. In this radial to be 0.0753, this will reflect to the velocity of average velocity, which is 3.18 meter per second. Alright, different radial position will have different corresponding velocity. Alright, so after we get the radial position, next we need to find the wall shear, which is tau naught. Alright, so this is step number 8. Okay, step number 8, we need to find shear stress tau naught using the equations of this one. Remember our friction factor, which is tau naught over with 1 over 8 rho v squared. Okay, so we rearrange the tau naught become the subject, which is tau naught 1 over 8 rho v squared friction factor. Okay, so from here we discover that the friction factor is 0.02. Okay, this is the average velocity. 1.8 multiply with 1000 density multiply with average velocity 3.18 squared multiply with friction factor 0.002. So your tau naught shear stress on the wall, this is referred to the wall, equal to 25.28 Pascal. Alright, this force created on the wall. The next question asks about the pressure drop across 10 meter. Okay, so this is step number 9. In order to get the pressure drop, okay, the change of P, we can get directly from this equation. Okay, from our shear stress, which is in this case tau naught equal to R naught over 2. This is actually the change of pressure over L. Okay, rearrange back, we will get 2 tau naught L over with R naught. Okay, so just substitute the value 2 multiply with tau naught. Okay, tau naught is 25.28. multiply with the total length given is 10 meter over width R0, which is 20 millimeter. We convert to SI unit, 0.02 meter. Finally, you will get the pressure drop over 10 meter is actually equal to 25,281 Pascal. Or you can simplify further, 25.3 kilopascal. Alright, so that is the pressure drop across the length. And then the last question asks the maximum velocity using this equation, 7, 6, 16. Okay, again the question asks U max. What is the U max using the particular equation? So step number 10, find the U max using the given equation 7, 6, 16. So what is the equation of this? Okay, this equation is actually referred to U max. Okay, you can refer to the Potter book, U max over U tau equal to 2.44 ln U tau R0 over with R plus 5.7. Okay, so in this case, we need to find the shear velocity, U tau. Remember that in order to get the U tau, we can square root of shear stress over density. So let's find the U tau first, which is our shear stress. We discovered previously 25.28 Pascal. So 25.28 over 1000. Square root both sides, we will get 0.159 meter per second. From the U tau, substitute in this equation, you will get, okay, U, this one, put the bracket, and then move U tau to the other side, multiply. And you will find U max equal to bracket 2.44 ln, this is actually ln the whole distance. Okay, U tau we discover to be 0.159 multiply with R0 is 0.02 over with the, this is actually the mu, alright, our kinematic viscosity. In this case, at 20 degrees Celsius, 1.007 multiply with 10 to the power of negative 6. This is the whole bracket plus 5.7. Multiply with, remember this U tau, which is 0.159. And finally, you will discover that U max is actually equal to this bracket 25.36 multiply with 0.159. The final answer is 4.03 meter per second. Alright, by using this equation, we discover U max is 4.03. By using this equation, alright, we discover that U max equal to 3.4 meter per second. Alright, that is the difference. Therefore, that is the final answer to get the U max, to get the pressure drop, the radial position, the friction factors, and so on. I think that's all. Thank you very much.